Okay, so this time around I want to use Jupyter Notebook and I want to start from the very beginning. So I'm going to close everything I have open here and start out with Anaconda Navigator. So if you get in here, you can launch a Spyder from here, or you can type in Spyder directly at your bottom left window if you're using Windows. So I want to show you how to use Spyder. It's very useful for visualizing your data frames while you're programming, and that's why I'm using it for um, this workbook. So the important thing is to come in here, you see File Explorer, and there is a browse window here you can use to navigate to whatever the file you're looking for is located. So if you download the entire zip file from GitHub and you extract it, you can come to topic 11, and these are the files you will find in there. I might add some more, but the interesting thing to note is this one. So this is a new folder and it has lots of actual production data. Now, this is not the data from the vol field. We will later work with the data from the vol field. This is somewhere else, I believe in Texas. 17 of them, and they are all in the same format. So we can pull open one of them. Okay, it's already open. DCA underscore well space 1.xlsx. And this is the content of the data. And what we're going to be loading will be this. So this is your monthly oil production rate. And obviously time is in months, going from month 1 to month 24, meaning you have how many years of production? 2 years of production. These are your decline curve parameters, which you all are very familiar with because we've worked with this several times. Initial flow rate, units of barrels of oil per day. Initial decline rate, percentage per year. B, which is your B exponent, decline exponent, usually a small number between 0 and 1 or slightly more than 1, which is the case here. And the important point to note is these monthly rates are not in barrels of oil per day. They are monthly rates, so they are in barrels per month. So the barrels of oil per day have been multiplied by the number of days in each month to get these numbers. And the standard way or the easiest way to convert daily rates, so let's say we have 2,000 barrels of oil per day and you want to convert it to barrels of month per day, the standard way is to multiply it by the average number of days in a month. So if a year has 365.25, why 0.25? Because once in 4 years you have a leap year, so that's a quarter. 1/4 is 0.25. So every average year is about 365 years and a quarter days. So that's this. If you divide that by the number of months you have in a year, which is 12, then you get the average number of average number of days in a month. I should have increased the size on this the whole time. So 365.25 divided by 12 gives you the number of days in a month on average. So to convert any of these from monthly oil rates to daily oil rates, barrels per day, you will divide by this number. So this is your average daily rate, and it continues to decline, right? Yeah, the reason is because G3 is moving. So I can fix it by putting the pound in front, and it continues to decline. And if you want to convert this to barrels of oil per month, then you do the opposite of that, which is to multiply the barrels of oil per day by this, which is the number of days in a month on average. And that's how we pretty much got these numbers. I'm walking through all of these because we're going to be making these calculations in the Python code. So for this project, or for this assignment, this is the important data set and this. So we're going to create two data tables, but we'll store these values for all the wells, and we'll store these rates for all the wells. We can calculate cumulative production ourselves. It's as simple as being equal to this for the first month, right? First month of production, monthly rate, same as cumulative in that month. The following month is the sum of these two. And another way to get the sum of these two is to get this cumulative for the previous month plus cumulative for this month. And that's what this is. Cumulative for the previous month, which is this, plus cumulative for this month. And that gives you 207. And you can scroll down on this and you get that. The function that does this in most programming languages is called cum_sum. It's also available in Excel, I believe. Cum_sum. And it basically keeps, well, you're going to have to apply it across a row. So it's not available in Excel, but it's available in most programming languages. So it's going to get all these rates and give you this. It's just cum_summing, meaning what's above plus what's above. This is the cell you're interested in, right? What's above plus the current month. When you come here, sum of everything above plus up to this point. When you come to month 4 is this sum. When you come to month 5 is this sum, and it keeps going that way. That's a cumulative sum, and the function is called cum_sum, and you will see us use that. So I spent so much time on this because I'm not going to be opening this when we start to write the code. Let's check out well 2. Open as read only. Looks the same, and the interesting point is that this starts at D4, right? Column D4. So column D4 all the way to D6. It's the same for all of the spreadsheets, D4 all the way to D6. Same here. This guy starts from B10 and it goes to B33. B10 to B33. B10 to B33. So B is the column header, and 33 is the row. Why did I show you that? Because we're going to assume, and we know for sure that's the fact, that all of the data in each of these Excel spreadsheets are at exactly the same location, and that is true. So when you come down here, you see there are 17 wells going from well 1 to well 17, and they have exactly the same file format. Good, so let's get into Python. We're going to navigate to that location. So where is this? I know where this is. You should know where it is for your program, wherever you downloaded and unzipped the file. So for me, it's in Documents, and in Documents, there is a folder. I can browse here, and I know it's in Documents, it's in GitHub, It's in this course, and we're in topic 11. Open. So inside this folder, there is another folder, and I'm going to talk briefly about file structure, and it's going to be tested in the quiz because it's very important. Anytime you run a code, this is the code we're going to be looking at. So I double click it and it opens it up here. It's lab 11, database and visualization. If I run this code and I'm trying to grab a file inside this folder, well, that file, those Excel sheets are not in this folder where the code is located. So if you try to access it like it's here, it's not going to work. So you need to be able to specify the full or the file path relative to where the code is located. So my code is in this folder, but the data, the Excel spreadsheets are in this folder. So you need to type first the folder name, then the name of the file. And this may look weird, but it's as simple as this. So file name is precisely this. This guy is 1, right? Above I set well ID to 1. So space 1, and it concatenates that with .xlsx. So this is exactly the name of the file we want. Well1. So well2 just changes to 2. Well3 just changes to 3, right? So to be able to change these numbers with our integers, I created a variable called well ID, and you can change this to whatever well ID you're interested in. For now, I set it to 1, and all of this is just string concatenation, which we talked about at the beginning of the course. The name of the folder, which is precisely this folder that contains the Excel file we're interested in. DCA_well space is common to all the Excel files, right? DCA_well space. The only thing changing is the well ID. So I leave the space here before the quotes, single quotes, then plus to concatenate the well ID. The well ID is an integer, so I want to convert it to string so that it's going to work with the concatenation operator. So I use the string function to convert it from a number, an integer, into a string. So it puts 1 here after the space. So you've got DCA_well space 1. Then you want to finish it all off with .xlsx, and you basically concatenate that to it. So this is how you're able to change well IDs at will by just changing this, because it's going to just put a number here, and you can move down from well1 to well2 all the way to well17, which is what we're going to do as part of the lab 11 workbook exercise. Okay, now that you know that, more details on file structure. So this was all nice and good because the folder was inside the same location as our code. What if the folder was up one directory? So you can go up one directory using this. What if the folder was here? What if I want to grab a file in this? Yeah, what if I want to use this file, 50startups.csv? This is just to, I'm not renaming, I just want to be able to copy it. This is just to illustrate how to access files from anywhere in your code. So the way you would access this will be to do, I'm just going to create another file name which I will delete. .. goes up one folder. So this is very important. Dot dot goes up one folder. So one folder will mean, so your code is here. This is the code you're running. It's here inside topic 11. So if you go up one folder, then you are in 30.2061 underscore 2028. And this file is basically a sibling to this one, right? Is it topic 10? Yes, topic 10. It's a sibling to topic 11. They are in the same folder. So you just need to go up one directory, and now you can grab whatever folder you want here, and the one we want is topic 10 underscore multivariate regression. Regress. So that has taken you into this folder. Then you now go to the file you want, / then 50 startups. So this is how you can use this double dot. It goes up one folder. What if you want to go up one more folder into the GitHub folder? Use another 2 dots. So 2 dots takes you into the GitHub folder, and you can grab any of the files you want. You could grab this folder instead of the one I had before by typing in PEDFM3D. So the way to think about it is in terms of parents and sibling and child. So what do I mean by that? Let's go back here. So this folder, topic 11, is a child of this folder, right? This folder, 2061 underscore 2020, is a parent to this one. And like I showed you before, topic 10, topic 11, topic 9, and others are siblings. So this is a parent to that. GitHub is a parent to this. Documents is a parent to this. So that's file path and file structure. So all of these double dots here, they allow you to get to a file using relative file path. So this is all relative to wherever this code is located. So we figure this code is located in topic 11, so we can start from there and go up one. And when you go up one, you realize there is a folder topic 11 in there, and in that there is this. So this is called relative path. This is a relative path. It's relative to the location of the code. If your code is elsewhere and you're trying to access a file that doesn't exist from that file path, it doesn't work. There is also the possibility of using absolute path. And this is how you get your absolute path. Just grab the entire file path here, copy it, Control-C, and you can paste it in here. And that will be absolute. It's going to change depending on the machine you're working on. On Windows, it will probably start with C, and there will be a colon, and typically it's going to be backslash in Windows, so you have to change it to /. So change all the backslash to / after you copy and paste in Windows, and that will make it absolute. So you will be able to run the code. You'll be able to access your folder regardless of the location of the Python code if you choose to do that. So you will work a little bit more with this later, but for now, I believe I've covered everything you need to know for file path. So there's absolute file reference, relative file path. And this is already in the same location as the code, so you don't need to go up one folder. You just need to put the folder name first, then the file. If you take out this, it's not going to find it because there is no DCAWell1 here. It's in this. So I'm going to pause the video here and create the next video that will now walk you through all of this. I believe now we've covered the basics of what we need to get into this code.